Okay, let's dive into the long-awaited strings. String is basically just a sequence of characters, and it's a data type. It's kind of a data type in Python. It's much more powerful. The reason, making this a whole new data type in almost every language is the reason is that almost all the data, all the text that appears in sequence of characters. So making that sequence of character the whole text as one kind of data type and writing special kind of functions to deal with that text might be necessary. And that's what string is. In Python, for example, you can declare a string variable s or any variable name by just double quotes, let's say a, b, c, or equivalently by single quotes. Either way is fine, d, e, f. So either way is fine. You can declare using double quotes or single quotes. Either way is fine. One thing is, be careful, don't mix, don't start by single quote and think that now I will end with double quote and that will be fine. So don't mix them together. If you're using single quotes, use single quotes. If you're using double quotes, use double quotes. Don't mix them together. That might be much more confusing later on. So let's say this S is a string. Python is the best language for data science. Let's say T is another string that is defined by single quotes. In this course, we are going to learn Python. Then you can print S in a different way. Let's say you can call a print S. You can call a print to T, or you can just, by the way, you can add two string variables S and T, and the result is a new variable. That's a V. How the plus symbol works in strings is, plus in strings means just concatenate them together. So first you just copy this string, the whole string, and then you just concatenate the other string with it, and the result is a new string. Now that's a new variable. You can use that variable and do a lot of stuff with it. So let's go to Python and see actually the prints the strings in the running form. So let's say S is string. Let's say Python is a good language, let's say, and let's have another string T that is using single quotes. It's good for data science, SCINC. Okay, it's good for data science. Let's run these two and see the type of S. What's the type of S? The type is str, string, str. That's what the type is. And if you just print S, that will be printed. Python is a good language. Remember, so far we are using this print, and always we use this kind of hello or something like that. That basically is a string because, by the way, this print function actually it takes an arbitrary number of arguments. We can print hello, then we can print anything in another type, then we can print another hello, let's say hello 2. That's a multi-variable argument function print. Then we can have another string, maybe who are you, and then maybe a floating point number 5.9. So we have used these kind of stuff a lot. We have used print function, and we were using these double quotes again and again, but these are actually strings that we were using later there. So this print function actually accepts strings and all these kind of, normally whenever you use print, normally you're going to actually display some text, and maybe you're writing that text into some file and so on. So this string is highly useful. Most of the data is available in the text form, in the string form, and we want to process the data, we want to find the anomalies in data, we want to fix them. Again, we want to stay in the text. So it is good to have a data type that actually have a lot of functionality that handles all that stuff. So let's see, for example, another Let's see how can we concatenate the two strings. For example, S and T. Let's say we have V, that is S plus T. That's concatenated V, and let's print V, and V is concatenated. Wow, Python is a good language. It's good for data science. Well, it is concatenated, but there is no space between two, because wherever the first string ends, the second string starts right from there. What if we concatenate three strings? S plus another string that just contains a space character, then this string. By the way, whatever that is there in double quotes or single quotes, whatever, one character, two character, all these things are called strings. So now we are concatenating three strings together: S, a space, one space string that contains just a space character, then T. And let's see what happens now. So Python is a good language, space, it's good for data science and so on. Wow. So yeah, so that's basically the introduction of string. What if we want, for example, to concatenate, what if we have a variable A, which is 12, and let's say we have a variable B, which is the price of this book. Let's say the price of this book, and A is 12. So let's say this is our price. Now price is in integer form, S is in book form. Let's say we want to make another string V that contains the following kind of thing: the price of this book is, and then whatever the price is, that should be there. So how can we do that? So let's say S plus maybe another string is, then maybe a space, so that after that the price appears. Now if we write plus and write price, price is no longer a string, it is an integer, and an integer cannot be concatenated with the string in a straightforward way like plus. How can we make a message like the price of this book is whatever the value of the price is? One way to do that is to convert the variable price, convert the type of the variable of price from integer to string. That means whatever the value, in this case 12, is written, that becomes a string of characters 1 and 2, and now it can be concatenated with the rest of the string, and we will contain the message that we want. So for example, if we now see what is V, that is the price of this book is 12. Oh, we don't have a space before is, so let's type a space there. Space is also a character, can be handled in string. Wow. So that's how we can convert different types to string. We can have a float type, we can convert that to string, and so on. Another way of doing the same or achieving the same kind of stuff is to write print the price of this book is, we can use the power of the variable number of arguments of, then price. That's exactly the same thing. The price of this book is 12, the price of this book. However, consider one thing: the print function automatically adds the space for different kind of arguments. You can see that here. Yeah, you need not to specify a space. The space is automatically added if it is considered to be a different argument in the print function. Okay, great. So that's the introduction of string. We are going to explore string much in a much more detail in the upcoming videos. So stay with us. We are going to see string in much more detail. Okay, hope to see you in the next video. A string might be very lengthy or may span, very lengthy and may span more than one lines. Or maybe the formatting is in a way that you want to, even if it is not very lengthy, you still want the different chunks of the same string to be appear in different lines. So there is a way to declare multi-line string, again using either 3 single quotes or 3 double quotes, and then 3 double quotes or single quotes, whatever convention you follow. And then you write all the string in no matter how many lines you want, and that one variable actually contains a multi-line string. If you now print, for example, if you call the print function on this multi-line, that's by the way a variable name, multi-line string that contains this data. Multi-line, multi-line, that the spellings are wrong here. I just written multi-line. Anyways, if you call that print function, the print will display this string as it is, like it is there. So let's see the, and by the way, the same multi-line string kind of fashion, remember that is used for comments as well. If you have comments that span on multiple lines, you can use this. So this multi-line string really is, if it is not saved in a variable and used as it is somewhere in the code, then that acts as a multi-line comment. Great. So let's practice the multi-line string in Jupyter Notebook. Let's see. So let's say we have a variable a that is a multi-line string, and let's say the string is, this is line 1, then we have this is line 2, and then we have this is last line, and this line is 3. That's it. Okay, great. That's a multi-line string. Let's see how can, if we print a, what happens. So this is line 1, this is line 2, this is last line, and this line is 3. Why this, this is shifted one character right. Oh, there is a space here. Let's remove that space if not required and run this again. Wow, because space is a character that will be printed if you want. Okay, what if you really want the following kind of stuff? You have, let's say, print. So what you really do is you want to print the following way. The following options are available. And the options are, let's say, tab, let's say hyphen a, and that does hyphen a, that does nothing. And then we have, let's say, hyphen b, and that also does nothing. Let's say you want our message to be printed in such a way. What will happen? Let's see. Okay, the following options are available. Hyphen a does nothing. Hyphen b, I mean, all this is a string, multi-line string. These characters that you think they are not there, these are spaces, and they are, I mean, the spaces are printed here. The spaces are printed here where you're seeing nothing is printed. These are the spaces that are printed there. So sometimes this multi-line string, it helps to format our message in a way that we like. So that's helpful in most of the cases. Further, if you write this multi-line, by the way, if you write this multi-line comment in the start and end of any code script, that means if you write this multi-line way of defining the strings at the start and end of any code script, that code script is commented. That we have seen several times earlier as well. So for example, in problem solving, remember that we define all, oh yeah, so that's the comment. That's a comment. Even if some code is written inside, that will not be executed. Great. Okay, so that's about the multi-line string. In the next video, we will see, because the string really is basically a collection of all these characters. What if we want to access a particular character? For example, this is the first character is T here, the second character is H, the third character is I, the fourth character is S, the fifth character is space, and all that. What if we want to access particular characters inside the string? Because a string contains a lot of characters. What if we want to play with some of the characters inside the string? How can we access different characters? For example, if I want to access seventh character of the string, how can we do that? So let's see in the next video how can we index different characters inside a string. Hope to see you in the next video. Okay, in this video we are going to actually access different characters inside the string, sometimes called indexing. The term slicing is basically more relevant to arrays, lists, or actually the mutable structures, but we will see. I'm just comparing because you may listen this term slicing again and again, but really it is indexing. But we will see the indexing or slicing sometimes is used. These two terms are used interchangeably. We will see the examples of slicing in detail in lists and in more detail in NumPy arrays. But here you just think that indexing and slicing are the same things. Index. So for example, I have this A, let's say this is A, array A, and I want to access its fourth element. Here the fourth character element is E. By the way, this A is a variable. If I want to access the very first character, the indexing, the number, the positioning starts from the integer 0. That's the first character. So if I want to print out of it, that will print G. If I access, for example, if I write the index 3, what do we mean? That means the fourth element. The fourth element is E. What will be printed? What will be printed if I access the fourth element, or the index 4? If I access this thing, a space will be printed, and you will be seeing nothing, because when a space is printed, actually nothing colorful is printed there, and you might be thinking, oh, nothing is printed, nothing have been accessed. Actually a space character have been accessed. So yeah, we can actually access a substring inside a string as well. For example, we want to access, for example, a substring starting from index 3 and all the way up to index 8, but does not include the index 8. So it will include the character at index 3, which is E, character at index 4, which is space. Let me write space in this way. Character at index 5, which is O, character at index 6, next character, which is F, then a space, which is 7, and then the character at 8. So this is not included to be accessed. This is included. This is inside. This is included. This is not included. So we can access a substring. So starting from 3, ending at 8. Let's see an example, and we'll come back to this slide again after a few minutes. So let's say we have a string S. Let's say, how are you? And who are you? Let's say. So let's say that's a string. Okay. And what we really want is we want to access, for example, we want to access the element. To access the elements, you have to write the square brackets. That's a standard notation in Python. Whenever you have a collection and you want to access different elements, that collection might be a string. That collection later on we will see might be a list, maybe a tuple, dictionary, maybe a set, maybe a NumPy array, maybe a pandas structure. I mean anything that is a collection. Normally it is accessed by, if it has different elements and we want to index them, the indexing notation is square brackets. And indexing always starts from 0 rather than 1 in Python. There are some languages in which the indexing starts from 1. For example, MATLAB, the indexing starts from 1, but in Python and in several other languages, the indexing starts from 0, which has some benefits over starting with 1. It has some benefits. So starting with 0 is okay. So let's say we want to access element at index 5. The element at index 5 is actually the 6th element in the string starting from 0. So first, second, third, fourth, fifth, sixth. So R will be printed. So let's see. R is printed. Let's check the type of this return value. Let's check the type of this this one element, which is R. What is the type of it? So type of different elements in a string, different characters in a string. What are the types? So what is the type of it? So the type is also string. So each and every character is also of string type. In some other languages, the type might be a character. Character is another type, but in Python, each and every one character is also a string. More than one characters is also string as long as they are accessed from a string. Okay, let's access, for example, the element number 3 to element number, let's say, 8. So the result is R. So element number 3, not 3, actually starting from index 3, which means the fourth character, which is space, and then RE, and then space, and then we finish. If we, for example, move from 3 to 9, let's say, and the value will be RY, or we may move to, for example, we may start from the very beginning. So for example, the index 0. We may end at the index 10, but not including the 10. So the result is how are U and YO and not the U included, because that's the index number 10, and index number 10, the last index, is not included. Great. We can have negative indices in strings as well. So a negative index is just the indexing from the right side, not from the left side. For example, a negative index, so -1 points to the last character, for example, U. Similarly, -2 points to the second last character, and so on. So -1, let's say, it will access U. And similarly, we have -3, and that will access Y. Or we may have start from, let's say, -8 and go till -3. That means go back to -8 index and then move to -3 index. Okay, and -3 in this case, let's see what's the result. R. Why is that? Why R? Oh, this R. I guess this R. Let's check it out. So this is -1, -2, -3. That's index number 3. So 3 is not included. -3 is not included, so it has to stop here. Okay, that's -4, -5, -6, -7, and -8. Oh, great. So that should be printed. It has printed. So let's say we have, rather than -8, we start from -12 and we reach to -3. So who are? Okay, great. So we have negative indices as well. And by the way, this kind of fetching this kind of substring is sometimes called slicing. I mean, we are just fetching the slicing. Although the term slicing is much more popular in mutable data structures. What is a mutable data structure? What is a immutable data structure? Well, yeah, I should tell you right now. You cannot change any character in the string. That might look like a bad news for you, but once the string is created, the elements in the strings are not changeable. So for example, let's say at position number 1, you want to place a character, let's say E. That's not possible, and the reason is the string is a data structure. The string is a variable type, a data type that is immutable. Immutable or unchangeable. Once created, you cannot change its contents. They stay fixed. You cannot change them, you cannot alter them, you cannot delete certain contents from it. I mean, once created, it stays as it is. You can copy this into another string. You can copy and paste, but you can get a substring and copy into another variable, for example. But the contents of S cannot be changed. So all the kind of data types in Python that are unchangeable, the contents are not changeable, they are called immutable, and string is immutable. So the term slicing makes much more sense, or it is more popular in the data structures that are mutable. that are mutable. Although you can use the term slicing, indexing both interchangeably, but it refers to fetching a substructure or substring. In this case, in the list, it will be a sublist or so on. So that's what slicing is. Yeah, great. Why don't we do some more fun with this string? Yeah, let me show you more fun with this string. More indexing. Let's say you start at index 0, you go to index 12, but not including 12, and then you take a jump of 2 rather than 1. What will it do is, it will fetch all the characters starting from index 0 all the way to index 12, but not including 12. But it will take a jump of 2 rather than taking a jump of 2. So first character, then take a jump of 2, then pick a character, then take a jump of 2, and then pick a character. So it will actually pick every other character starting from 0. So let's see that. So for example, if you remember the string, that's the string. So it starts from H, fine. Then it skips O and go to W. Then it skips space and go to A. Then it skips R and go to E. Then it skips space and go to U. And then it skips O and go to U, and then the 12th achieved, and we stop there. Wow. So the general way of slicing or indexing, the general way is you have a start index, start, then you have end index, and then you have a step size. If you do not mention the step size by default is 1, that we were doing already. If you do not mention the end, the default end is till the end, the total list size. If you do not mention the start, the default start is 0. For example, let me make that a comment and just practice a few. For example, let's start from 0. We do not mention the start. Let's start from 0 and go to 12. If you do not mention the starting index, that starts from the very beginning, 0. Go till 12. Okay, great. If we do not mention, for example, we start from 3 and we do not mention the end, that means go till the end, starting from index 3, including the last character. Okay. If we do not mention the step, for example, if you start from 1, go till 12, and we do not mention the step, the default step is 1. Okay. There is one way of reversing the string. I mean, very beautiful way. I mean, you do not start the mention. You do not mention the start. You do not mention the end, and then just take a step of -1. In this particular way, the start and end index, they are just swapped, and you get the string reversed way. Wow. So that's the reverse string. Isn't that fancy? Yes, it is. Okay. A lot about indexing. You can find out the length of any string by using len function. You can find out the length of any substring if you want to, if you have a substring, using again a length function, len. That's okay. Okay, now we have seen how to access substrings and how we cannot change the elements of a string because it is immutable, but we can access them. We can just display them. We can analyze them and so on. In the next video, we will see some functions that are supplied for string processing. What we can do with strings, and I mean, how can we manipulate those strings? Although we cannot manipulate the contents of a string, but we may copy a string, we may get a string, manipulate it, and save it to another variable, and what kind of functions that are available in string data structure, string data type. So let's see that in the next video. Hope to see you in the next video. Okay, let's see different functions that are available to play with the strings in this string data structure. Let's say you have this string a lot of spaces. These are a lot of spaces at the beginning, and these are a lot of spaces at the end. There are some spaces in the middle as well. So there is one function called strip. All the functions of the string, they are called by taking a dot something. These are called methods. You can loosely call them functions, but those kind of functions that are related to some data structure and called with dot, they are sometimes called methods. The term method is more related to object-oriented programming. Actually, string is a class, so all these are the methods. But even without knowing that, it's perfectly okay. You can call it method or function. That's perfectly okay. You can, I mean, it's okay. It's okay without knowing what a class is, without knowing what an object-oriented programming is. This a dot some function that operates on this a. One difference with method and function is when you call a function with a dot and you call some function, let's say a dot strip, then inside the definition of the function, this a object or the a variable is available, like you have passed that variable as an input argument. That's all you need to know about the difference of method and function. The rest of the story is perfectly okay even if you don't know. That's fine. Okay, a dot strip. It operates on a, which means the a is passed in this function as just as input argument, or it is available there inside the function implementation. And then the strip function, what it does is it removes all the spaces that are in the beginning and removes all the spaces that are at the end, and returns another string that has no spaces at the beginning and no spaces at the end. And the new string is copied or created in a variable b, let's say, whatever that variable, we can have another name of that variable. So let's see the running form of this strip function in our friend Jupyter Notebook. So let's say a is a string variable. Let's say a lot of spaces, a, b, c, d, e, f, a lot of spaces, then h, g, q, and whatever, and then a lot of spaces. Let's say this is a, and then we have b. Let's say a dot strip. Okay, and let's print b. So b is actually everything without spaces, without the starting spaces and without the ending spaces. It does not hurt the spaces inside. So that's a strip function. Sometimes processing the data, when we read the data from a file, it may have a lot of spaces at the beginning, at the end, maybe due to formatting issues or something like so, and this function is available if we want to remove those spaces from beginning or from the end. Let's see more functions. Another function is lower. Like the name suggests, it actually converts all the string to lowercase. For example, let's say we have a string. Let's say let's say we have a string a equals a, b, c, d, e, f, g, and some characters, some other characters, and q, f, let's say. That's a string. And now what we do is b equals a dot lower. What it does is it converts all the string to lowercase. For the characters that are already in lowercase, it doesn't hurt it. For the characters that has nothing to do with lower or uppercase, it doesn't hurt that. All the characters that are not in the lowercase and can be converted to lowercase, those are converted to lowercase, and this is available. Yeah, great. So similarly, we have another function called upper. For example, c is equal to a dot upper, that like the name suggests, it converts all the characters to uppercase. Wow. Let's see more functions. Oh, there is a function replace. The replace function, what it does is it takes a substring and replaces that substring with another substring. Okay, let's see it. For example, let's say we have the same a. Let's say the a is this thing. Let's say that's a. And what we want to do is we want to replace the semicolons, let's say, with the semicolon. We want to replace the semicolons with statics. So what we can do is we can say, okay, d equals a dot replace the semicolon with let's say static, or yeah. So let's see what d is. So each semicolon is replaced by a static. By the way, if you if you want to replace, for example, a dot replace, if you want to replace one semicolon with a string, for example, the string is star star and hat hat person person. That means one semicolon will be replaced by this with this string, and the other semicolon will also be replaced by this string, and the result will be as expected. Each semicolon will be replaced by this string, and that's the result what it is. Further, if you want, for example, let's say d equals a dot replace. If you want this particular substring that contains the two semicolons, if you want the two semicolons to be replaced by another substring, let's say two semicolons, that's it, then that is also possible. I mean, you replace one substring with another one. Yeah, great. There is one more function called split. That what it does, what the split does is, for example, you have a string, for example, let's say a equals a string, let's say ABC, then you have this colon, then you have DEF, then you have semicolon, then you have HGY, this, then semicolon, then you have YY3223, and that's it, that's your string. Let's say you read that string from some CSV file and this appears, and now what you want all these values to be separated out that are separated by the semicolon. Maybe these are different values. ABC is a different value than it is separated by a semicolon. Semicolon may be an indication or token that the next value started, and so on. Let's say you want to separate them. Let's say you want to just split them, all of them, with a particular splitter, and here let's say the splitter is semicolon. So what you can do is you can have a list and a dot split, and in the split you can specify the character that is used for splitting after and before we split that. And remember, the split function actually returns a list of strings where this is the first element of the list, this is the second element of the list, this is the third element of the list, this is the fourth element of the list, and so on. Because once you will split, you will be having different elements that are splitted out. So if you print, for example, L, you will be having a list of different strings, ABC and all that. Oh, don't worry about this single quote. The single quote and double quote is the same thing. Now we can access, for example, the third element or maybe the second element by index 1, and the second element here is DEF, and we can work more on that. Okay, is that it? I mean, are these the only functions that are available? Strip function, lower, upper, replace, and split function. Or is that it? That's all the string is about? Maybe there are more functions. How many functions are there in string? How can we use them? What are the total number of functions? Where is the list? Where is the documentation? Should we follow some book? Should we go to some tutorial and find all the string functions and see how to use them? Well, if you want to do that, you can do that, but there is another smart way. Let's say A is a string that you know. You write a dot and then press tab, and all the things that are there in string, they will appear in front of you. I mean, several things. You can go to this, you can go to that, you can go to that, and so on. So just you can check the documentation of A. For example, if you press A, then what it does, let's see. It's a string object and all that stuff. Fine, it's a string. So further, what we can do. So let's say A dot, we press A and then we press tab. Is there anything that starts from A? No. Is there anything that starts from B? No. Is there anything that starts from C? Yes. Capitalize, case fold, center, count. These are the functions that are available that starts from C. Okay, let's focus on capitalize. Okay, what is that thing? How to use it? Let's press colon, question mark, and see what this is and what it does. Okay, so here is the documentation. Here is the doc string. Returns a capitalized version of the string. Capitalized version of the string. Is that the same as upper? Maybe. So let's see. Now we know what it does. Let's just check it out. Print A, capitalize, and see what's the result. Oh, it's no, it does not capitalize the whole string, does it? The string A was, it does not capitalize the whole string. What is A? Let's see, what is A? A is the following string. A is the following string, so it does not capitalize the whole string. Oh, the difference between the capitalize maybe and the upper is that the capitalize, when it encounters no, capitalize just capitalizes the first character. Let me read the doc string again. Returns a capitalized version of the string. More specifically, make the first character have uppercase and the rest lowercase. Okay, that means if we have a string that has a mix of values, the capitalized will do the following. It will convert the first character to uppercase and all the rest of the characters to lowercase. Wow, that's an awesome function. For example, if you have string A, B, D, A, F, D, and G, G, Q, let's say, and then we call capitalize, let's say. So what that does is it actually capitalizes the first character and all the rest of the characters there as it is. And there are other functions as well. A dot, let's say count, what it does. A dot count, what it does. A dot count, what is that thing? Let's check it out. Or maybe we can check that out using help. What is A dot count? So let's see what is A dot count. It's a built-in function. Count method is an instance of, and it returns a number of non-overlapping occurrences of a substring. Sub in, oh my god, if you I mean that's what is written there. Non-overlapping occurrences of a substring. Great. Oh my god. So basically there are a whole lot of functions of strings that are available. There are several uses of the string. There are several ways of molding and playing with the strings. Some of the functions are available. Some you can make your own. You can make your own modules on top of that to customize your according to your requirements. A lot of these are available, and you should know how to use them. First thing, if you want to do something with string or with any data type in Python, first check whether some method is available or not. And one way to go that is just right away from here. Another way is to go to internet and see, I want to do this in Python with strings, whether there is a function available or not. The good chances are there will be a built-in function that is available. And in that case, I will encourage to use that function rather than to write your own one, because using the built-in function or the method that is tied up there will be much more faster probably than the function you will be writing at your end, even if you're too smart in algorithms. So yeah. So that's about the string methods. There are so many other methods that are available. In the next video, we will see some more manipulation and processing and some more working with strings, and then we will move to other data structures. Okay, hope to see you in the next video. In the last video, we saw some methods of string, and these are just a few of them. A lot of them are available. We just discussed some of them. In this video, we are going to talk more about strings in a particular way. For example, what if you want to find out whether a particular substring is there in a string or not? Let's say you have a string and you want to know whether a particular substring is there inside a string or not. Well, you can easily find out that using the in keyword, and similarly not in means the reverse of that, or the complement of that or not of that. And in keyword always will return either true, a boolean, or false. If it is inside the string, it will return true. If it is not inside, it will return false. So let's check this, the implementation of that in Jupyter Notebook. So let's see. So let's say we have a string ABC, and we want to check whether this string is there in this particular string or not. So the return value is false because ABC as a substring is no longer there. A is there, for example here. AB is here, but ABC is no longer there. Yeah. So if we, for example, have an ABC somewhere at least once, then the result will be true. In the last to last video, or maybe in the very first video for strings, I showed you that you can use plus with strings. Can you compare two strings using less than or equal to? I mean, how to compare two strings, whether they are same or not. For example, ABC, let's say that's a string ABC. I want to check whether that string is the same as ABC or not. What will be the result? So the question is this double equal to can be used for comparing two strings? Well, the answer is yes. What will be the meaning of less than? A string is less than the other. Is that true? For example, ABC is less than, let's say, DEF. Is that true? If it is true, for example, what does it really mean? How can we define one string is, I mean, this string is lesser than the other string? Maybe this operator is working based on the length of the strings. But even if that, then this length is the same as this length. And to be more precise, we can change that length, for example, by just saying, okay, ABC, DEF, GHI, and I guess this string will be still smaller than the right string. So how this comparison is working? Well, I guess the comparison is working based on the alphabetic order, and you know the alphabetic order. A becomes first, then B, then C, and all the alphabetic order that is there in English dictionaries. That's how the strings are working here. And the alphabetic orders for all the special characters will also be defined in Python. For example, that's a special character, for example. Maybe this string. Is this string smaller than the following string? Yeah, return true or false. Because there is particular ordering in Python that is defined for these characters, that this becomes first and this, like A becomes first then B, B becomes first and C, and so on. So whatever the alphabetic order is, based on that order, you can compare the two strings, no problem. So these are also available. And the third thing is in function that is also available to check whether a particular string is inside, a substring is inside or not to in another string. One more thing that I want to talk about in that, for example, what if your goal is to print the following? Let's say you want to print the following. We are learning, and let's say you want to print the string in double quotes. We are learning string here. Let's say you want to print this. You want this string to appear in double quote. How can you do that in Python? Well, it looks like same. What's the difficulty? Let's call the print function and then just write here we are learning, then write the double quote here, string, and here. That's it. But there is a problem. The reason is when we call this, when we write this double quote, actually the string ends here. Exactly, the string ends here. And when we write this single quote and this double quote, another string starts here. And this is no longer a string. I mean, it has no data type inside. Well, how can we then insert these double quotes inside? Well, there are several ways. One way is to use escape sequence, and escape sequence is just like, it is, you use a slash and then whatever you use is considered as a character inside the string that is you're using. And now if you want another double quote, you use a character which is the backslash or maybe a forward slash. And if you use that, that means whatever that is coming in front of it should be used as it is, rather than considering that that's a special string defining symbol. Now in this particular case, you'll be having your double quotes available, and the backslash will be just out. It is just defining that don't touch this double quote. It has nothing to do with defining a string. It is just because I want to highlight this word. Another more easy way is to use the single quotes. For example, we are learning, and use the double quotes as a character inside that. Now the single quote, wherever it starts and ends, they define the string. Everything else is a character. We do not need a escape character where we want. Okay, great. And there are a lot of escape characters. For example, we have we are \n. That means go to new line. We are now on another line. So this \n actually puts everything that comes after to a new line. That's an escape character. Similarly, we have an escape character \t that actually inserts a tab whenever we want. So if we are, then a tab, then now on another line, now on another tab, whatever. So there are a lot of escape characters. I mean \n, \t, there are other. So it is good to know those. One more thing that is important. For example, let's say you want to print some address on the drive. Let's say C \, backslash or forward slash, whatever that is called, name \drive. Let's say you want to do that, and your goal was to just print that path. What will happen is this \n will be treated as a new line escape sequence, and \n will tell, okay, go to the next line and treat the rest of the things. But because \d is not any escape sequence, it is not listed inside, it is treated as it is, and that way this slash is also treated as a character. But here, because if this slash followed by this n, that's a combination that is already there for a new line, that is treated in a different way. If you want this to be used as it is, and you don't want these, you don't want this behavior, you just want that all this should be treated in a very literal or raw sense, then you should just apply an R there, and R will tell, okay, that's a raw string, everything inside, just treat that as a raw string. There is no escape sequence inside. Great. So and there is much more about string we can talk, but that was the most important that I told you, at least to me. We can explore this more. Actually, you should now explore this more. What are other functions of string? How can we play with strings in another way and stuff and so on. If I talk about strings, I can just, I can give a whole course on strings as well, but here I just give you a snapshot of strings. If you need more about strings, you should be searching on internet or seeing documentations and seeing basically what you want according to your requirements. Search the functions. Probably they will be available. Okay. In the next video, we are going towards list, tuples, sets and dictionaries, some other data structures that we were talking about earlier. We will be going to explore them in more detail from the next video.